So as I told you now, let us go to latches. So in latches, there are different latches. We have SR latch, we have S bar, R bar latch, gated latch, and D latches. So now, if you understand the first one, definitely it will be easier for you to understand the rest. So let us now understand the SR latch. With this SR latch, I will try to give details, more details as possible, so that we may understand fully. After understanding this SR latch, it will be easier for the rest of latches, even flip-flops, even counters, even registers. So now, friends, let us start by the SR latch. What is the latch? First of all, what is a latch? The basic storage element. The basic storage element is a latch. As the name itself, latch, even we have latches at our homes. When we lock the door, when we latch the door, someone inside will not come out. The same thing, if we come to digital latches, it means we want to store, we want to keep, we want to latch a 0 or a 1 inside the circuit. We want to memorize that. If we have set the latch to 0, let us keep that 0 inside. If we have latched the 1, let us keep that 1 in the circuit so that we can store it. So a storage element, the basic storage element is a latch. Good. So let us start now by the SR latch. The SR latch can be built using a NOR or using a NAND. You can build a latch using a NOR or using a NAND. If you don't use a NOR, use a negative AND. If you don't use a NAND, use a negative OR. These are the equivalent. So now, here on this circuit, this is a NOR, this is a NOR, this is a NOR SR latch. Good. So now, let us see this NOR SR latch, how will it function? So before going very far, let us remember first of all, the truth table. Let us remember the truth table of a NOR latch, a NOR gate. Let us remember the truth table of a NOR gate. Having two inputs, where X is the output. We have 4 combinations, of course, with 2 inputs. We will have 4 combinations. And with 0, 0, NOR gate, that is a 1, 0, 0, and 0. Good. So friends, this is the truth table of a NOR gate. Good. So we will come on it. Now, why are we using these letters R and S? R stands for reset. R stands for reset. And S stands for set. It stands for set. When normally a circuit is reset, when this circuit is reset, means when R is activated, Q is equal to 0. Q becomes 0. But when the circuit is set, Q output is 1. So that's why, friends, it means this R means reset, this S means set. Good. Now, how this circuit will it function? How this circuit will it function? This circuit will function, let us start by the first case, by resetting the circuit. So let us, case number 1. Case Case 1, it is where we reset the circuit. Means S is equal to 0, R is equal to 1. R is equal to 1. So we reset the circuit. By resetting the circuit, of course, Q will be equal to 0. So what is Q bar? What is Q bar now? Now, if we reset the circuit, means R1, S0, and then Q is equal to 0. So if Q becomes 0, this 0 as the input to the, well, let us say this is G1, G2. So Q as output 0 will be input to G2. So now it will be 0, 0. So in case of 0, 0, even if you can see the truth table, even if you change just 0, 1, even if you take 0, 1, whenever you have a 1, the output becomes 0. It means with this 1, 1, the output will become 0. Well, here we don't bother about B, because even if B is 0 or 1, whenever we have a 1 for a NOR gate, the output is 0. So now, if you put 1, 1, I repeat, 1, 1, 1, 0, 1, 0, directly, the output is 0. Q is 0. Now, as the reset, of course. Now, if Q is 0, take 0 to this, to G2, 0, 0. So 0, 0 will give us a 1. 0, 0 will give us a 1. So Q bar is equal to 1. Q bar is equal to 1. Good. So friends, in this case, we have this output. Now, we want to keep this output. We want to keep this output, this 0 and 1, in the memory, to remain inside the circuit, to be latched there. Now, what will we do? We have to memorize this. We have to memorize this. Now, by memorizing, you have to change the inputs, because the input can change. We have to change the inputs. So if you change the inputs, or we remove the inputs, simply we remove the inputs. So let us remove the inputs. Let us remove the inputs. Okay, 0, 0. So it will remain 0, 0. So means I have removed the inputs. So I have removed the inputs, 0, 0. Now, if I remove the inputs, what will happen to Q and Q bar? What will happen to them? So as our previous output, we have it, remember, as our previous output, you have to use the previous output. Now, take the previous output, 0, take it to G2, 0, 0, we will have a 1. So Q bar is equal to 1. Take this one. If you take 1, bring it there, 1, 0, 1, 0, 1 there in this case, 0, 1, it gives the output 0. So you see that Q also is equal to 0. So now, friends, you have seen that by removing the inputs, the output remains the same. There is no change. There is no change in the output. So we have the same output when we have removed the inputs. So it means this case, when S is equal to 0 and R is equal to 0, we remain, there is no change in the previous output. That's why this is called memory. This is memory. It means we are memorizing the previous output. We are keeping the previous output. Good. So now, this is the first case. Let us see the second case. Case number 2. Case number 2 is where S is equal to 1, R equal to 0. Good. So now, what will happen to Q and Q bar? And Q bar. What will happen to them? So let me rubber all those inputs and outputs. Okay. Let me rubber them. what will happen? What will happen to them? Good. So here we are saying that S is equal to 1 and R is equal to 0. Good. So dear friends, I have said that set. We have set. So if we set directly, Q is equal to 1. Good. So here we have R is equal to 0 and S is equal to 1. Good. So now, in this case, Q is equal to 1. If Q is equal to 1, bring that 1 to G2. So 1, 1, 1, 1, the output is equal to 0. Take that 0. Take that 0. 0, 0, 0. The output is equal to 1. So, and then Q is equal to 1. Take 1, 1, 1, 0. So you see that here, in this case, Q is equal to 1 and Q bar is equal to 0, which is right. Good. Now, friends, let us again memorize this. Let us memorize this. So we have to take S is equal to 0, R is equal to 0, and what will happen to Q and Q bar? What will happen to them? Good. So friends, the same. Our previous output 0. It's okay. So remove the inputs, set as them to 0, 0, and then the previous output 0. Take it there 0, 0, 0, 0. The output in NOR gate is 1. So Q is 1, right? Take 1. Take 1, bring it there. It will be 1, 0. 1, 0. It gives an output 0. Good. So you see that we are keeping the same output. Q is equal to 1 and Q bar is equal to 0. So we are not changing anything from the previous output. So this case also is a memory. This is a memory. Good. This is also memory, because we are memorizing the same output that we had previously. Now, let us see a case where, case number 3, where S is 1, R is 1. So what will happen to Q and Q bar? What will happen to them? Good. So friends, let us rubber and see what will happen. Let us see what will happen. Now, what will happen? We are setting S to 1 and R to 1. Set, reset. So if I reset means 1, and I set means 1. Now 1, 1. It's okay? 1, 1. Remember, friends, whenever you set, whenever there is a 1, whenever there is a 1, Q, the output is 0. So means Q is equal to 0. Now, if you set the circuit, normally if you set the circuit, Q, even if, let us say, if we reset, Q is 1, Q bar is 0. Q is 0, Q bar is 1. If we set, Q is 1 and Q bar is 0. So you see that in this case, when you reset, Q is 0, and when you set, Q bar is 0. Now, Q is 0 and Q bar is 0. This is not possible, because Q cannot be 0 and Q bar be 0. This is not possible. This is the most complicated case. Q cannot be 0. If Q is 0, Q bar cannot be 0. Q should be 1. But now, even though it is not possible, let us see if we can memorize. Let us keep only this output. Let us say Q is 0, Q bar is 0. Let us see if we can keep this data in the memory. So keep this data in the memory. That is S is equal to 0 and R is equal to 0. Good. Now, let us start by Q. Q, the previous output, is equal to 0. Now, what will be Q bar? Okay, take 0, bring it there. So we have changed the inputs to 0, 0. So take this 0, bring it there. Good. So 1, 0, it is 0. Good. Now, you see, if you take this 0, 0, Q is equal to 0. Now, bring it there. Bring it. 0, 0. Good. So 0, 0, it gives a 1. You see? So now Q is equal to 1. Q bar is equal to 1. In this case, this is correct. But look at the previous output. We are not keeping the previous output. This present in output is not the same as the previous output, which is not memorized. This is not memory. Even if we start by the Q bar, if you start by Q bar, what will happen? If you start by Q bar, what will happen? If Q bar, what will happen also? We want to memorize. Start by Q bar. Now, if you start by Q bar, 0, bring it there to G1. 0, 0, it gives a 1. It will give a 1. You see? It will give a 1. Now, if it gives a 1, bring this 1. Come it to G2. 1. So it gives a 0. So Q is equal to 1 and Q bar is equal to 0. So you see that in both cases, if you start by Q or Q bar, you will find that we are not memorizing this data. So this case is not used. Or you can say it is invalid. This is an invalid condition. So, according to what we have, when S is equal to 1 and R is equal to 1, this is an invalid case. This is an invalid condition. Is not used in the SR latch. So now, friends, this is how the SR latch functions. Now, can we now draw the truth table of this SR latch? So let me remember this side. And then we find the truth table. The truth table of SR latch, where we will have S and R as inputs and Q bar as outputs. So these are inputs, Q and Q bar are outputs. Now, with 2 inputs, 4 combinations as usual, 4 combinations and 1, 1. These are the 4 combinations when we have 2 inputs S and R. So as you have seen, when S and R 0, 0, when SR 0, 0, we have seen that in both cases, case number 1, case number 2, that is memory. Or you can say no change from the previous output. Now, the case number 1, 0, 1. When it is a 0, 1, the output Q is 0 and Q bar is 1. This is the case of latch reset. Now, second case, case number 2, S is equal to 1, R is equal to 0. We have 1 and 0. That is latch set. The latch is set to 1. The latch is reset to 0. Good. So now the case number 3, this case is invalid. This is an invalid condition. This is an invalid condition, or it is only not used. It is only not used. So dear friends, this is the summary of the SR latch, and I hope it is understandable, because I have given the very much details on it so that you can understand. So dear friends, repeat again, rewind again and understand. If you understand this SR latch, this will be easier for you to understand the rest of the latches. So now, in few minutes, let us see this Nand Latch. This Nand Latch, it is the opposite of the NOR latch, because it will be like this. Let me rubber. It will be like this. You can use all the steps we have done. You can use all the steps we have done. We will use a NAND. We use 2 NANDs. Let us say this is G1, G2. Now, the output Q bar will be coupled. It's okay. Like this, will be coupled like this as inputs to G1 and G2. So now, as I said, it is an opposite to SR, to NOR latch. This will be S, this will be R. Good. So now, friends, in this case, the truth table will be like this. The truth table of NAND SR latch. Good. So this is the case of NOR. This is a NOR. This is the NOR. This is the NAND. Now, what will be? What will be? It will be normally in some books we write this S bar R bar to mean the opposite, or the active low. This is an active low. Active low. This is an active low latch. While this one is active high. This is an active high latch because it is high. It is resetted. It is resetted when it is 1. It is setted. It is setted when it is a 1. See, 1 1. So it is an active high. While this will be an active low. Now Q bar 0 0 0 1 1 0 1 1. Okay. So as I told you, if you start case number 1, case number 2, case number 3, you will find the following. This will be invalid. This will be invalid. While this will be memory. You see now, it's somehow reversing. Now, when it is 0 1, we will have 1 0. We will have the 0 1. So now you see that it is set. It is set. This is latch set, latch reset. This is a latch reset. So it is set. It is set to 1 when S is 0. It is reset to 0 when reset is 0. You see. So now you see now this is an active low, and this is the brief. That is the brief truth table of this Nand Latch. So if you have understood the first one, use the same procedures for this circuit, you will find this truth table. So in brief, this is how an SR latch is functioning. And I hope that this will help you to understand the flip-flop, registers, counters, and other sequential logics. Thank you so much.